In this video, I will reveal the hidden cost of poor forging equipment and how it quietly eats into your margins, delivery performance, and credibility. If you plot a simple pie chart of total cost, many teams see 5 to 15% silently going to rework or excess machining, sorting, and warranty returns. Most of that does not come from material or labor. It comes from equipment capability and process control inside the forge shop. Hello, I am Rahul Agarwal, Managing Director at Precitech Forgings and Engineering. I am speaking today as a practitioner who has seen how good equipment discipline can make or break a program. Why does this matter? Your job is not just to buy parts, it is to protect your production, brand, and cash. Every week, sourcing and supply chain leaders are juggling piece price, timelines, PPAPs, and customer changes. You are measured on-time delivery and cost, yet you are blamed for line stops and failures that often result from upstream process weakness. The truth is, $1 savings at RFQ can become a $50 loss after late deliveries, extra machining, and field claims. The earliest leading indicator is often hidden in the forging equipment and how it is run. Let me paint the shop floor picture many of us have seen. The press is rated correctly on paper, but the frame is tired, the ram is not parallel, and the guides are worn out. Parts pass PPAP at low speed. At high speed, you get lapse, underfill, and scatter in dimensions. Billets are heated by feeling. There is no reliable temperature log, and die preheat is inconsistent. One batch flows like butter, the next fights the die and chews your tools in machining. Lubrication varies shift to shift. Too much causes burns and porosity, while too little causes sticking and die breakage. Load cells and energy monitors exist but are not calibrated. Operators are chasing pieces, not signatures. Die life is not at all tracked. Instead of preventing changeover, the tool fails mid-run and your delivery window closes. On your side, it shows up as stock variation causing extra machining passes, fixtures getting jams, sorting cost at incoming, and that uneasy feeling when a PPAP looks fine, yet your gut says this would not be stable at volume. Here is the counterintuitive truth. The best predictor of forging cost and reliability is not the new press or the lowest piece price. It is the stability of energy, temperature, alignment, and maintenance culture. Material certificates do not create mechanical properties. Controlled deformation at the right temperature does. A mill certified bar can still become a weak part if the die temperature and energy delivery are wrong. Another overlooked fact is that most of your machining costs are a function of forging consistency. When the forge delivers steady stock and clean surfaces, you cut fewer passes, burn fewer inserts, and keep cycle times tight, while equipment drifts every downstream minute becomes expensive. Use this simple Forge framework when you audit or shortlist a forging supplier. F. Fundamentals of equipment. Check press rigidity, ram parallelism, guide wear, and effective energy delivery, not just rated tonnage. Ask for recent alignment reports and bolster flatness data. Observe at a rate, listen for chatter, or look for die bounce. O. Oven and die heating control. Is billet heating by induction with validated temperature checks? Are pyrometers calibrated? Is die preheat controlled and logged? Is there a soak time discipline? Ask to see real temperature logs linked to batch IDs. R. Repeatability in production. Are load energy signatures monitored and trended per part number? Are sensors used for misfeed, part out, and loop control? Is there a first off and in process check plan at defined intervals? G. Governance and maintenance. Preventive maintenance schedule visible. Spares for critical items in stock. Calibration records for presses, pyrometers, and load cells current. Die life tracking with planned changeovers, not reactive fixes. E. Evidence and transparency. Traceability from heat to dispatch. Non-conformance handling clear. Basic capability data. CP or CPK on key forging dimensions available. Will they share OEE or simple run charts during ramp up? 5 quick questions you can ask on any visit. Show me the last 3 alignment or calibration records. Question 2. How do you know a billet is at the right temperature before the press? Question 3. What is your typical die life and how do you decide to change it? Question 4. Can I see today's energy or load signatures for this part? Question 5. When was the last unplanned press downtime and what did you change after? A mid-sized agriculture equipment maker was fighting variable cycle times and sporadic cracks on a forged yoke. On paper, their supplier had a suitable press and good material, but on the shop floor, die preheat was manual and the press alignment had not been checked in months. They introduced 3 basics from Forge: formal die preheat with logs, a weekly ram parallelism check, and live energy signature monitoring. Within 1 quarter, their scrap went down significantly. Machining passes came down by roughly 1 pass per part, and missed shipments were reduced because unplanned tool failures dropped. Nothing fancy, just disciplined control of the fundamentals. The big idea is that the piece price is visible, but process stability is not. Poor forging equipment and weak controls don't send an invoice, they leak money into every corner of your supply chain. Shift the mindset from can they hit my price to can they hold my capability at volume. If you audit with the Forge framework lens, you lower the risk, you protect schedules, and often reduce true total cost without a single price negotiation. As you plan your forging supplier review, ask yourself, where in my forging supply base am I trusting paper more than process? I would love to hear your experience. What is the one silent risk you have caught or missed in a forging shop audit. Share it and let us learn together. See you in my next video.